I've talked about that box experiment where we have a ball here and ball here, and we go here at 12 o'clock and 12:01. At 12 o'clock we observe it here, at 12:01 we observe it here, and then we ask ourselves, how did it get there? And that's an assumption of persistent existence that makes us, if we observe the mowing a little bit here, that it's been mowing in a tractor here, and that this is the same object as this thing here, but it's just been mowing, it's displacing itself in space from here to here. That's the assumption we make. If we look at this experiment, what we know is that when we don't, in between here, it has some wave-like behavior. That is, it's not the particle here. That's what it means. It's not the particle, because if it was a particle, it wouldn't be able to create the interference pattern. So at C, when we don't have that observation at C, when we don't try to detect it, it goes through the slits as a wave-like thing. And it goes as a wave-like thing through the slits, whether it is a particle or a wave. It behaves the same. And if we try to detect it here, we will find a particle here. Whether it's light or an electron, we will find that particle there. And if we use an assumption of persistence of existence, then we may say like, yeah, okay, so it was a particle that went from here to here. It was a particle that went from here to here, and a particle that went from here to here. But I've explained in previous videos that you can't use that assumption that it's a particle that moves here. You can't use that assumption it's a particle that moves here, because it would not create the interference pattern. And it kind of proven, because if we try to detect the particle here, then the interference pattern goes away. And we have this particle pattern here. So if we try to confirm that it is a particle, the interference pattern goes away. And then you may say like, yeah, so it's a particle, because that's what we detected. But I'm telling you, you need, and I've told you in previous video, you need the wave description to be able to predict these behaviors, the interference pattern and the particle pattern, because the wave description is a prediction of what's going to happen. You cannot do these predictions, neither of these predictions you can do with a particle description. So what we can say here is the following. Particles doesn't exist. What exists is an observation of something. That is, say, an event exists. There is something, an event is something that happened at a specific time, at a specific position. As I wrote in my summary, quantum mechanics says there is events in space, and these can be correlated with each other. And this is exactly what's going on here. So the particle doesn't have a continuous existence. The only sense it is a particle is that is located somewhere in space. And then after a little time, we could make a new location in space. And I've earlier defined a particle as being something that has a position and a velocity. And the velocity we can determine from two observations, but these particle observation is not we don't observe a particle because there is no particle. We observe an event, and then we observe another event. And that event we call a particle. But you have to realize it's not a particle, because it's nothing, it doesn't exist such thing. Because a particle, when we're talking particle, we're thinking of an object with an independent existence. But it doesn't have an independent existence. It only exists during that time you're observing it. So it's a volatile thing. And in between the observation, it does not exist. It's a field here. And why do I say it's a field? Because light is a wave, because it has this wave nature, but it's in physics it's treated as a field. Light is treated as a field. It means it exists, I've said this before, it exists everywhere in space. And when that particle is a crest in that field, and that, since it's light, is a crest that moves at the speed of light from here to here. The same thing is with an electron. It's a field, but it's not an electromagnetic field. It's an electron field. So when you send out an electron, it also creates a crest here in the field. Before you send out that photon or that electron, that field is zero here. That is to say, there is nothing there. Zero, nothing. And then you hit the start button and you send out one photon and you get a crest there. In the case of the light, it goes with the speed of light over here. In the case of the electron, well, the speed can vary. It depends on the amount of energy you're pumping into the system here. It could move very, very, very slowly, or it could move fast. You can actually make electrons go in at the speed of the light too, but then you have to pump in a lot of energy. And you have to have like that particle accelerator you have in CERN in Europe. And I tell you, they have to pump in a lot of energy to make electron go that fast. But anyway, electron moves slowly. So that means that we usually can catch them in the flight here. And we get these observations all the way here. So and because it travels slow, and because we can make all these observations along its reactor, we have made that old, we have used that old assumption of persistence of existence for electrons. And then said, yeah, okay, if it's a particle here, particle here, particle here, then it's probably a particle in between. And that's an assumption we bring from our everyday living experience about electrons. So it's natural to make that assumption. So it's natural to think about electrons as particles. But there is no such thing as particles. They don't exist. It's an event you observe. It's a field. And yeah, I have a little bit more time, but I think I'm going to stop here. The point I want to make is that light and electrons, they behave the same in the two slits experiment. And the way they behave is like a field. They are both field, they're two different fields. This is an electron field, and this is a electromagnetic field. And the reason we think light is a wave is because it moves so fast that we've never been able to like track it in its path. And light has always come like huge amounts of light particles. If you turn on your light at home, you fill the entire room. The entire room is full with photons, and there is no way you will see that individual photons. You always see them in huge amounts, and this means that the particle nature of light has been hidden for us in our everyday living experience. In the same way, electrons are waves, But they are so slow-moving and they are so few in numbers that whenever we look at them, we don't see that wave behavior. Actually, nobody has seen an electron, but you understand what I mean. That because they are so slow-moving, we could detect them so often that we say like, yeah, here it is, here it is, here it is, here it is. So we make that assumption that it's been traveling here, and it is a persistent object that is persistent of existence, but it doesn't. An electron is like the particle nature of an electron is a figment of our mind. It's based on an assumption which is not true. So the event exists, but the event is not persistent over time. So in a sense you could say there is a particle there, but you have to understand that the particle doesn't have a persistent existence. So that means that there is something that happens here, and that thing here, yeah, is it the same or not? I'm not going into a discussion about that right now. I mean, is that crest here? Is that crest here the same as this crest here? I'm not going into a discussion about that, but I'm just going to say that after you made that observation is an observation. It's an event. It's not a real thing you observed. It's an event. The event is real, but it's not that, like the Greek thought about the smallest undividable unit of matter. It's not that thing we're talking about here. And with that, I'm going to end here.